All right. Cool. All right. So what I want you to do, I want you to try this problem. So this problem is gonna be just not a recap of what we just did, but it also gonna go back to the multiplication rule. So I want you to try out this problem because this is a good example of like how we could combine what we just learned with the multiplication rule. So take a minute and try and do that. If you get stuck throughout any of the part A, B, or C, just either chat me up or just, well, just talk to me and I'll try helping you out. But try doing A, B, and C, and we'll go over it together in a bit. But try doing this one right now.
No. That's not right.
All right, so let's go over this one. So if you look at the problem, it says the iPad has a 4-digit code where each digit has to be a number from 0 to 9. It is okay to use the same number multiple times for the code. So for this one, how many number do I have to choose from?
10.
Cool. So we have 10 numbers. And the reason we have 10 numbers come from 0 to 9, there's 10 numbers including the 0. All right. So for this one, when we're selecting a passcode, is it possible that I could just use the same number or do I have to use different numbers?
No, you can use the same number.
Cool. So you can use the same number because if you look at the last line, it says it's okay to use the same number multiple times for the code. So that's why this is not a permutation or a combination, because it's okay to use the same number. So what we're actually going to do, we're going to use the first thing that we learned today, which is the multiplication rule for counting. So when I'm selecting the first pass, well, when I'm selecting the first digit, how many numbers do I have to choose from?
10.
I'm a little confused because I thought it was the combination rule.
Well, the reason it's not the combination rule, well, there's two reasons why it's not the combination rule. Because one, the number can repeat. So anytime the number can repeat, it's not permutation or combination. Because that's one of the distinct things that make it a permutation or combination, that none of the number could repeat. The other reason why it's not a combination rule, because right here the order does matter, because the way you enter the number into your iPad or your iPhone, whatever it is, it will make a difference, because either gonna make it that it's correct or not correct.
Okay.
So how many numbers do I have to choose from when I'm selecting the second digit?
10.
Still got 10.
What about when I'm selecting the third digit? How many numbers do I have to choose from?
10.
Cool. What about the fourth digit?
10.
Cool. And for this one, all we're gonna do is multiply 10 times 10 times 10. Let's go pretty much 10 to the fourth power. So we'll do 10
Yeah.
to the fourth power. And you get 10,000.
Okay, that's what I got.
Everybody go for A.
Yeah, that's what I got.
Yeah.
Perfect. All right, let's do B. So for B, said, what are the probabilities some random person will guess the correct code? All right, so how many correct codes should there be?
1.
1,000.
What?
Oh wait, 1.
And then you do out of 10,000. So we'll say
No 1.
1 divided by 10 to the fourth power. Cool. You get 0.0001. So it's not very likely somebody will just randomly guess your password. All right, but that's it for B. Any question for B?
Nope.
All right. So this is where C come about, and this is where the multiplication rule, you want to use the multiplication rule. So for this one, it said the iPad will give a person 3 tries to unlock the iPad. After the third attempt, the iPad will self-destruct. So it said, what are the probability the iPad will self-destruct if a random person is trying to guess the correct code? So for this one, would it self-destruct if they guess the correct password, or would it self-destruct if they get the incorrect password?
Incorrect.
Incorrect. So that means we want them to, if they have 3 attempts, we want the first attempt to be wrong. We want the second attempt to be wrong. And we want the third attempt to be wrong also. So if you look at this one, you're doing multiple selections because you have 3 selections. So since you're doing 3 selections, that's why you want to use the multiplication rule. Cool. All right, so what's the probability that the first time they attempt it, that they'll get the first attempt wrong? So the bottom should be 10,000. How many wrong selections are there, or wrong passwords are there?
9,999.
Cool, 9,999. All right, so we're good for that one. So that's a probability to get the first attempt wrong. Any question on that first probability?
No.
All right, let's do the second one. All right. So for this one, if they're smart, once they select a wrong password, they're not going to select that wrong password again because they already know it doesn't work. So that means that they only have 9,999 wrong passwords. 9,999 passwords to go. But of the 9,999, how many of them won't work?
9,998.
Cool, 9,998. So if you look at this probably changed for the second time. So that way this is dependent. Cool. So let's do the third one. All right. So what's the probability that the third attempt will be wrong? So how many total passwords are there for that person to try out?
9,998.
So how many of them are wrong?
The 97.
Yeah.
So,
And if you just do some basic simplification, you get 9,997 all over 10,000, which will give you 0.9997 or 99.97%. And that's it. So that's kind of like a combination of what we just learned right now and the multiplication rule. So the multiplication rule, the reason why we're using the multiplication rule, because we're making multiple attempts on trying to open up this iPad. Because if I just want to know the probability of you doing one random guess, you have to do that. But since we're trying to do multiple selections, that way you want to just multiply them out. All right, but that's it for chapter 5. Any question in regard to chapter 5? Cool. All right, so for your quiz on next Monday, is actually you're gonna be on this that we cover right now. So if you're okay with this, what we cover right now, you should be good for next week quiz on the 13th, April the 13th.
may I see the top 2 problems again, which were A and B, real quick?
Oh, A and B, yeah.
Okay. All right, gotcha. I know what I did. Oh, we're good.